Welcome to Chapter 5. Chapter 5 will be looking at all different kinds of graphing. First thing we're going to take a look at is slope. So today's topic is the rate of change and slope. Let's warm up with some things that we've done in the past. Take a moment to answer these three problems. Let's see how you did. In order to figure out if 1.50 is a solution to the equation, we need to substitute them into our formula. So when we do that, substituting in the 0 for y and the 1.5 for x, we come up with 0 plus 3 equals 3, and 3 is equal to 3, so therefore it is a solution. To solve this equation for y, we need to get y all by itself. So we need to first get rid of this minus x by adding x to both sides, and then to get y all by itself, we divide everything by 2. So we have y equals 2 plus x over 2. And finally, to graph our function f of x equals x plus 3, we make a table of values. Remember, we use our standard x's, -2, -1, 0, 1, and 2. We substitute those in for our x here. -2 plus 3 is 1, -1 plus 3 is 2, 0 plus 3 is 3, 1 plus 3 is 4, and 2 plus 3 is 5. Plot our points. -2 to the left 2 and up 1, -1, 2 to the left 1 and up 2. 0 means we move no left or right, we just go straight up to 3, over to 1 and up 4, and over 2 and up 5. Connect your points with a straight line. Slope we see everywhere. We see slope and we think of slope when we go skiing. If you're out riding off-road, if you are on a slide, that has a slope. Stairs have a slope. Construction zone here has a slope, and the roof here has a slope. So we see slope everywhere. So what is slope? Slope is the ratio of the vertical change, also known as rise, to the horizontal change, also known as run, between 2 points on a line. Slope is also called the rate of change. So we're going to have several ways to look at slope in this section. Today we're going to look at it mainly as the vertical change over the horizontal change, or rise over run. So again, rate of change shows the relationship between two changing quantities. When one quantity depends on the other, the following is true. The rate of change is equal to the change of the dependent variable over the change in the independent variable. So we can take a look and figure out slope when we have a table. In order to see our rate of change in our table, we have to do exactly what we did in the last chapter. Figure out what happens in this column and figure out what's changing in this column. So in the first column, in the time column, we are increasing by 1, and in the distance column, we're increasing by 260. So our rate of change is going to be the change in distance over the change in time. So 260 over 1, or just 260. So when we go to graph this, graphing those ordered pairs, in order to get from one dot to the next, we would move to the right 1 unit and up 260 units. This is a linear relationship. When data are linear, the rate of change is constant. Notice that the rate of change is just the ratio of the vertical change to the horizontal change between 2 points on a line. This is also known as the slope. Again, slope is vertical over horizontal, or rise over run. Let's take a look at an example. It says to first label each point on the graph with its coordinates, draw a vertical arrow to represent the rise, draw a horizontal arrow to represent the run, underline the correct word, and then figure out the slope of the line. So, labeling our points, this would be -3, 1. This point would be 2, 3. Now, to represent the rise, we have that in red here. If you're going up, that's positive. If you're going to the right, that's positive. So we have a positive rise and a positive run. Since our rate of change is constant, we have the slope of a line is 2 over 5. Another example, we are going to figure out our rise over our run. Now we have two options here. We can either go down, which is negative, and to the right, which is positive, or we can go up, positive, and left, which is negative. Either way, one of our rise or run is going to be negative, which means we're going to have a negative slope. So if you go down 2, that would be -2, and then +6. Or if you go up, that would be positive 2, and left, negative 6. So either way, you're going to come out with a slope of negative 1/3. It just depends on which way you choose to count. Another example. Here we went up 1, 2, 3, 4, and over 1, so our slope would be 4 over 1, or just 4. Your homework assignment tonight is on page 296, numbers 8 to 16.